Hey everyone, this is me attempting to give you a little bit of help with this Euler's method practice set. It helps to kind of think through the process with an organized chart like this where n is our step, and we're always going to start with step 0 with some basic facts, which is that when x is 1, y is 2. All right, and then we're given an equation, sometimes another chart that tells us the value, but what is the dy dx? I'm sort of mixing up my notation here. Just could have called this f of x, and I could have called this f prime of x. But right now we've got this simple little equation that tells us that we just add the x and the y values, so very simple. So we get the slope at that point, right? If we were drawing a slope field, we'd have the slope there to be a rather steep 3. And then the idea with Euler's method is that we're not drawing the entire slope field, we're just going from point to point. We start here with that slope, and we just continue that forward until we've completed our x step, which in this case is just 2 steps going from 1 out to 3, means our step size is a very convenient one. If it had been 4 steps from 1 out to 3, our step size would be 0.5. So you just simply subtract and then divide by the number of steps. In this case, we can project that forward relatively easily and get that the new point is going to be 3 units above where we are, 2. But let's formalize that a little bit. Our delta x, then, we can figure out what it is. In this case, it's 1. It'll vary from problem to problem. The delta x, then, is just going to be the product. We're going to multiply these two values. If we know our steepness and we know our width, we can get the delta y by just multiplying. Then we're going to take this, for emphasis, we're going to take this delta y amount and add it onto our y, just like we would have taken our delta x value each time and added onto our x. So if we're going by 1, then this will become 2. If this was 2, then when we add on our delta y of 3, right, because we're multiplying whatever this is times the step, that's going to be plus 3 will give us a 5 value for our y. Then we just repeat. That's our first step. Our second step then will be, well, we find the dy dx by adding these according to our formula right here. It'll be different from problem to problem, so that's 7. Then when I multiply by 1, I get 7 again. So then when I add that 7 plus 5 here for my third step, my f of 3 will give me a value of 12. So that's what I want to type in there is 12. All right. On the next problem, if I use this chart, oh, by the way, just to fill in the idea that here we were up around 7. That's actually relatively close drawing. And then the steepness there gets even steeper, and it goes zooming up, and then we project that forward. So then just remember what this chart looks like, because we'll use it perhaps in the next one. And hopefully I've typed everything in correctly. On to the next. Okay, so now this is the last one. They're giving us a k value that we need to solve for. But we can do that by just simply thinking about, all right, we've got our chart down here. Here's n, there's x, there's y. I'm going to write y prime this time just to keep it simpler. And then there's the delta x, and then there'll be the delta y. Okay, so when we start off at 0, our x value is 3. Our y value is k. They're not telling us what that y value is, but they're telling us that this is the formula. So if I plug in 3 for x, that's 6, minus 2k, and then 6 plus 3 is 9. So I know that whatever it is, it's going to be 9 plus 2k. Does that make sense? Hopefully so. I'm just plugging in my x and my y value up into this equation and working out what is